Hello everybody. Today we're going to continue our notes from yesterday. So I am starting with the day 3 portion of your notes. And remember, these are the notes that we started yesterday. And I'm on about halfway down page 3. We are looking at this day 3, writing explicit formulas for our arithmetic and geometric sequences, which we learned about yesterday. Couple formulas we are going to need to use, and these two formulas will be given to you on a reference sheet. So the good part is you don't need to memorize them. We need to be able to write explicit formulas for both arithmetic sequences and geometric sequences. And I'm going to take a look first at the formulas that we get as they are shown on the reference sheet. Here's our formula for the arithmetic sequence, where we have our term a subscript n equaling a1. A1 is the first term of the sequence. So this a1, first term. And then we add to that whatever our n value is, minus 1, multiplied by d, which if you remember from yesterday, this d is our common difference. That's the number we were practicing to find if we had a set of numbers. Now, we have to remember in this formula, this n is a subscript, and it is the first, second, third, fourth term, whichever term we're looking for, 1, 2, 3, 4. We'll go over more of that as we do some examples here. Well, there's our formula for an arithmetic sequence. If we are looking at a geometric sequence, our formula looks a little different. It actually is modeling that exponential function like we talked about yesterday. If I want to find an nth term, that is term a subscript n, then I multiply a1, and again a1 is the first term in the sequence, so I substitute that in for a1, multiplied by r, which is what we were finding yesterday. That r is the common ratio for a geometric sequence. But that r has to be raised to a power, and that power is this n minus 1 again. So if you notice, n minus 1 here is also showing up in our arithmetic formula. It's important that we're going to need to be using that n minus 1. And again, n is the number of the term that we're finding. All right, well, let's go ahead and start with some examples because I think you'll see a little bit better what's going on in that case. We are going to start with this first example. We are going to write an explicit formula. That means I want to write either an arithmetic or geometric formula for a particular sequence given to me. And I've got some steps that I can follow. First step, step 1, I want to take a look at my sequence of numbers and decide if it is an arithmetic sequence or a geometric sequence. So step 1, decide arithmetic or geometric. Now, if you remember, I want to look at what's going on from one term to the next and see if I can figure out the pattern here. On this first one, it looks like if I think about adding a number every time from 2 to 6, I would be adding 4. But from 6 to 18 does not give me adding 4, so that's not going to work. So maybe if I multiply by something, 2 times 3 gives me 6. 6 multiplied by 3 gives me 18. 18 by 3 gives me 54. That works, which means if I'm multiplying by the same number, in this case, then I have a geometric sequence. So for a geometric sequence, if I'm going to write this formula, I need to, once I know that this is a geometric sequence, and I know that because we are multiplying previous term by a constant. In this case, our constant is 3. So I know I have a geometric sequence. I need to, in order to write the formula, I need to identify A1. A1, which is my first term of the sequence as we set up here. A1 in this case is equal to my first term, 2. Next thing I want to do is substitute this A1 value of 2, and I want to substitute my R value. You remember from yesterday, R is that value that we're multiplying by every time. In this case, I'm multiplying by 3, so R is equal to 3, and R is that common ratio. Well, I want to take both of those numbers, that A1 and that R, and I want to substitute it into my geometric formula. My geometric formula, right from this box up here, my geometric formula says A subscript n is equal to whatever A1 is, multiplied by whatever R is, to the n minus 1 power. Now, all I'm going to do to get my formula is substitute in the 2 for A1. So this is getting replaced with a 2. And I'm substituting in a 3 for R. And I'm going to rewrite my equation. So it becomes, bringing down my A subscript n equals 2 goes in for A1 multiplied by 3 to the n minus 1 power. I leave the A subscript n in my formula, and I leave an n. Let's write that down as a note. Only make sure we spell correctly. Leave A subscript n and leave n in the explicit formula. And we're done. Moving on now to the next example. I want to find a formula for this new sequence of numbers, going from a 1 to a 3, 3 to 5, 5 to 7. Looks like I'm adding 2 to my previous term each time. If I'm adding the same number, then I know that this is going to be an arithmetic sequence. And I know from yesterday that I have a value of D, my common difference, and that is that number that I'm adding each time. So D is equal to a plus 2 in this case. And the next thing that I'm going to do then is follow my steps. I've already analyzed the sequence, and I decided that we have an arithmetic sequence. So I'm going to identify A1. A1 is my first term. So first term of the sequence, very first one, it's a 1. And I want to identify the common difference, which we did. D is our plus 2. I want to substitute both those values into my formula for an arithmetic sequence. Now that formula from our other page is equal to A subscript n multiplied by, well, actually we don't multiply yet. I'm going to rearrange it though in a moment for you. This is going to be A1 plus n minus 1 multiplied by D. I'd like to rearrange that for you so that it looks a little bit more like what we get for our linear equations. The only thing is, when you get this formula on your reference sheet, it's going to look like this. If I do a little rearranging, I'm going to, since I usually have things that we distribute out in front of parentheses, I'm going to write it like this, D times n minus 1, and then I'm going to add my A1 value. This kind of mimics our y equals mx plus b, only I'm going to substitute in now values for d here and values for a1. When I do that, I get a subscript n is equal to a value of 2 for d times n minus 1, and plus a value of a1, that's 1, so I'm putting 1 in. Now I'm going to distribute and simplify. 2 times n is 2n, 2 times a negative 1 is a minus 2, plus 1. Got some like terms here we can combine, negative 2 and plus 1. This will give us 2n minus 1. So my formula, bringing down my a subscript n, formula is a sub n equals 2n minus 1. All right, example number 3. I'm going to write an explicit formula for this next sequence. Got to figure out what's going on. Don't think I'm adding the same number every time, probably multiplying. Since my numbers are getting larger, probably multiplying. Let me see if I can figure out, what do I multiply 0.5 by to get 3.5? That thing we multiply by, if indeed we multiply by the same thing, that's our r value, our common ratio. So I'm just going to use r. And if I want to figure out what that r is, I'm going to divide both sides by 0.5. And I get r equals 7. 3.5 divided by 0.5 is 7. So I know at least if I multiply 0.5 by 7, I get 3.5. I want to check to see what happens now. Will that work also to go from 3.5 to 24.5? Let me check that. If I take 3.5 and I multiply that by 7, see if I really do get 24.5. 7 times 5 is 35. Carry your 3. 21, 22, 23, 24 with one decimal place. Yeah, that does work. Looks like if I multiply by 7 each time, I'm going to get my sequence of numbers. So now I know r is equal to 7, and I have a geometric sequence. So now to write the formula for a geometric sequence, I'm going to use my standard form. A subscript n equals a1 times whatever r is to the n minus 1 power. And then I want to substitute in for a1 and for r. So I need to know what's a1. Well, that's the first term. First term in my pattern, 0.5. And I need r. We already determined by multiplying by 7. So I'm going to substitute those values in, bring down my a subscript n, put in 0.5 for a1, multiply that by 7, take that to the n minus 1 power, and I'm all set. If you want to put parentheses around these values to show your multiplication, that's fine. Don't have to, but certainly not a problem if you do. So there's my formula all done. Number 4 now starts to be something a little bit different. I'm not writing an explicit formula at the very, very beginning. The instructions say, find the 10th term. And then it says, oh, but wait, first find the explicit formula for this thing. Then use the formula. So use the formula to find the 10th term. So I'm not going to find that 10th term that it talks about in the first part of this set of instructions. I'm first going to find the explicit formula. So I need to figure out, well, what kind of sequence do we have? 3 to 5, 5 to 7, 5 to 9. I think it's pretty clear. We're adding 2 each time. That means that we have an arithmetic sequence. And we have a common difference value that we're adding, and that's 2. So I'm going to write my formula first, and I'm going to use that a subscript n equal to A1 plus n minus 1 times D. However, I like to rearrange this. D times n minus 1 plus A1. All right, we've got D. D we said is equal to 2. We need A1, the very first term. 3. I'm going to substitute those in. A subscript n is equal to a D value of 2 times n minus 1 plus an A1 value of 3. Going to distribute my 2 and combine like terms. And our explicit formula becomes A subscript n is equal to 2n plus 1. Now we're going to use that to find the 10th term. So, to find the 10th term, if we're finding the 10th term, then that means then n is equal to 10. So I want to substitute 10 in for n. All right, if I do that into my formula, my explicit formula, A subscript n means A subscript 10, or the 10th term, is equal to 2 times 10 plus 1, or 20 plus 1. My 10th term, A subscript 10, is equal to 21. All right, now part B says to find n if my term is 209. I don't know if that's the 11th term, 12th term, 13th. I know it's something higher than the 10th term because the 10th term is 21. So I need to know, well, which term is this that's 209? Well, first I want to go back to my explicit formula, which I already know. A subscript n equals 2n plus 1. And now I know that I'm solving for a term that is equal to 209. I'm going to substitute 209 in for A subscript n. So my term is equal to 209. I need to know what term is that? First, second, third? Well, I know it's not those. 11th, 12th, 13th? Maybe. Let's see. I'm going to solve for n because that's what I'm finding here. Subtract 1 from both sides. 208 is equal to 2n. Divide both sides by 2. And I get n is equal to 104. Or in other words, the 104th term of the sequence is 209. This is the answer we were looking for. All right, we're ready now to go on to the next page. We want to find the 11th term of this sequence. All right, if we're finding the 11th term, then that means that n has to equal 11. But I don't have anything to substitute 11 in. I don't have a formula here. So I need to find my explicit formula. So I'm going to follow my steps. And first of all, I need to determine what kind of sequence is this. So I'm starting with a 1, and then I go to a negative 1/2, and then a positive 1/4, and then a negative 1/8. Looks like my signs are changing, positive to negative to positive to negative. That's going to indicate that I'm multiplying by some negative number. So I'm going to multiply by some value of r, but r must be a negative. All right then, if that's the case, then I know that if I take any one term, like my first term, and I multiply that by r, it's going to give me my next term. So to find r, I can just divide both sides by my coefficient here of 1, and I get r equals negative 1/2 divided by 1 is just a negative 1/2. And there's my r value. I know this is a geometric sequence. So I'm going to find my explicit formula using a subscript n equals a1 times r to the n minus 1. And I'm going to substitute a1. a1 is my first term, 1, times r value of negative 1/2 to the n minus 1 power. All right, knowing that now, I want to find the 11th term. So again, I want to put in for n the number 11. 11th term, 1 times a negative 1/2 to the 11 minus 1, which is 1 times a negative 1/2 to the 10th power, or that 11th term, if I put that all in my calculator, it's going to equal 1 divided by 1024. 1 over 1024 is my 11th term. All right, this next problem is a little bit different. So we are going to need to put together a couple things that are going to help us out here. On this problem and the next couple, sometimes it's a good idea to try and list out some of our numbers in the sequence as they might show up in a sequence. And here's what I mean. We've got to find an explicit formula. We know that we have an arithmetic sequence, which means that we're going to have a d value, or common difference. And we're given our starting number, a1. That's going to be 5. And then we're given the sixth number, 21. If I have a starting number 5, and then I have a second number, and a third, fourth, fifth, and a sixth number, here's a 6. My sixth number, is 21. My first number, or a1, is 5. That's followed by a2, a3, a4, a5, and then the a6. To get an explicit formula, when I know that I have an arithmetic sequence, I know that I'm going to end up using this a subscript n is equal to a1 plus that quantity n minus 1 times d. And again, I'm going to rearrange this. Eventually, when you're used to this rearranging, I'm going to go straight to this rearranged form. But for now, I'm going to start out with this, which is the same as you get on your reference sheet. All right, my explicit formula then, we said we need to know a1, and we need to know d. Well, with the information that's given to us, we know a1, that's 5. So I know I'm going to substitute in a 5 for a1, but I don't know what d is. So that's my missing piece that I have to figure out. Something times n minus 1. So I'm going to go back to my list of values here, my list of terms, starting with the 5. And I know that if I add something, I'm going to get the next term, add it again, and again, and again, and again. I'm going to get the 21. And each time I add a number, it's got to be the same number, because that's how an arithmetic sequence is. And that number that I add is d. I can use this to figure out what d is if I say, starting with 5, adding d plus, that's that one, plus another d, plus a third d, plus a fourth d, plus a fifth d, and I get to 21. That means 5 plus 1, 2, 3, 4, 5 of these d's equals 21. Now I've got an equation I can use to solve for d. Subtract 5 from both sides. We are left with 5d equals 16. And then we're going to divide both sides by 5. And we get d is equal to 16 over 5. That can't be simplified, so we're going to use that value for d over in our equation. So I'm going to take this value for d, and I'm going to put it in for my d value here. And I get a subscript n equals 16 over 5 times the quantity n minus 1 plus 5. All right, I'm almost there. All I need to do is simplify this. So I'm going to distribute the 16 over 5. Combine like terms. That would be minus 16 over 5 and a plus 5. And I'm going to leave it to you. To figure out what that is. Give you a moment on that one. Alrighty, I'm getting 9/5. Hopefully you got the same thing. If not, check your answer. If you think you're right, when we get together on Wednesday, you can present me with your answer and see if you get a starburst opportunity there. All right, I'm moving on now to number 7. Again, we're finding an explicit formula, this time for a geometric sequence. So I know I'm going to need this formula. And I'm going to need A1, and I'm going to need R. Looks like they give us A1, but they don't give us R, they give us A10. So I could try making a list of those values again like I did in the problem up above. 3 is my A1, and then that's the first term. I have a second, third, fourth, fifth, sixth, seventh, eighth, ninth, and then my 10th term, 1536. It's a little bit hard for me to guess what my R value is, but I do know that if I multiply 3 by R, I get the next term, and then by R again, I get the third term, fourth term by R, fifth term by R, sixth by R again, seventh by R again, eighth by R, ninth by R, and then finally times R to get the 10th term. So if I take 3 and I multiply it by R times R, let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 times that we're multiplying by R. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. We get this. This is the same as R to the 9th. Now to get R, I want to divide both sides by 3. I get R to the 9th is whatever this 15 over 36 divided by 3 is. And if you remember, to get R by itself when it's raised to the 9th power, I take the 9th root of both sides of my equation. So all I need to do is put that in my calculator, and when I do, I get an R value of 2. So now I know R is 2. I know my A1. That's my first term. A1 equals 3. R equals 2. And my formula becomes a subscript n equals A1 or 3 times 2 to the n minus 1 power. And again, if you want to put parentheses around that, you may. But there's our explicit formula. All right, one more problem here. We have an arithmetic sequence. Uh-oh. We've got letters. Our first term is K. Our second term is 10. Our third term is K plus 16. I want to know what K is, or in other words, what that first number is. All right, well, let's see. If this is arithmetic, that means that I add the same number each time I go to my next term. So K plus whatever D is gives me 10, and 10 plus D gives me K plus 16. So I can write this now as an equation. A couple ways I can do this. I can say K plus a D plus another D equals K plus 16. If I do that, I get K plus 2 Ds equals K plus 16. If I subtract K's from both sides, they will cancel out on both sides, and I get 2D equals 16. Helps me get my D value. Just divide both sides by 2, and we know D is equal to 8. All right, so that means I can substitute in an 8 for that D that I'm adding. So I'm just going to write that up here. I'm going to add 8, so I'm going to add 8 again. So this is plus 8, plus 8. And I'm going to put that back into, actually, all I need to do is say now K plus 8 equals 10. That's to get from my first term 8, plus, or excuse me, K plus the 8 gives me this 10. Then I can get to my K value. 10 minus 8 is 2. What is the value of K? K equals 2, and we are done. All right then, that is today's lesson with all the examples. You have a ticket out the door to fill in, and you also have some homework. So for the rest of the double period today, you're going to do the exit ticket, hand it in at the back table, and pick up the homework. All right, hope you have a great day, everybody, and I will see you on Wednesday. Thank you.